In today's lecture, we will discuss the mole concept and also molar mass, molecular mass, and the numericals or the problems associated with the mole concept. Let's review some of the terms which we discussed earlier in our other lectures. Atomic mass is the weighted average of the masses of the existing isotopes of an element. Formula mass is the sum of all of the atomic masses of all atoms in a compound as represented in a chemical formula. Atomic mass unit is the 1/12 the mass of a carbon 12 atom. This unit is used to express the relative atomic mass. Now the problem for the scientists was that there are too many atoms in a sample of a substance to count them all. Atomic and formula masses are measured in atomic mass units, but scientists measure mass in grams in the laboratory. What they needed was, number first, a way to count atoms without having to count them individually, as counting them individually was an impossible task. So another thing which the scientists needed was a value to relate atomic mass units to grams. Now the question was, how many atoms are necessary to make up a mass in grams that is equal to an element's atomic mass in atomic mass units? So the solution to this problem was the mole, which we will discuss in the next slide. So mole is a number equal to the number of carbon 12 atoms in exactly 12 grams of pure carbon 12, which is equal to Avogadro's number, that is 6.022 into 10 raised to the power 23 atoms. Now the Avogadro number is the number of atoms, ions or molecules present in 1 mole of a substance. This number is represented by a symbol Na, and its value is 6.022 into 10 raised to the power 23 atoms, ions or molecules. The importance of Avogadro's number is that it is used to calculate the mass of atoms, mole, and the number of atoms present in a substance. So what is mole? Mole is a unit like a dozen or m used to represent a particular number. A mole can be defined as the amount of an element that contains 6.022 into 10 raised to the power 23 atoms is called 1 mole. And how big is that? Well, a mole of marbles would cover the earth in a stack 50 miles deep. Mole of a substance is represented with small letter n. The moles of an element can be calculated as the number of moles is equal to mass in gram divided by molar mass. 1 mole always equals to 6.02 into 10 raised to the power 23 representative particles, and these representative particles includes atoms, ionic compounds, molecules, and formula unit. Molar mass is defined as the atomic mass of an element is also the mass of 1 mole of that element. For example, 1 mole of hydrogen is equal to 1.008 grams of hydrogen, which is equal to 6.02 into 10 raised to the power 23 hydrogen atoms. So mole establishes a relationship between atomic mass units and grams. Molar mass is the mass in grams of 1 mole of a compound. For example, sodium chloride. The formula mass of sodium chloride is 58.44 AMU, while its molar mass is 58.44 gram per mole. How we calculate the molar mass of substances? Let us take the example of methane. Its chemical formula is CH4. The mass of 1 mole of carbon is 12 gram. The mass of 4 mole of hydrogen is 4 multiplied by 1008 gram is equal to 4.03 gram of hydrogen. So the mass of 1 mole of methane is equal to 16.04 gram, or the molar mass of methane is 16.04 gram per mole. Now what we know about the mole is that it establishes a relationship between atomic mass units and grams, and 1 mole is equal to 6.02 into 10 raised to power 23 representative particles, and those representative particles may be atoms, ions, or molecules. Now how can the mole be used for convergence between mole and mass and moles and the number of representative particles? In the next slide we will do two examples regarding the conversion of moles into mass and moles into representative particles. First example is find the number of representative particles in 2.76 moles of HCl. We have the formula number of moles, which is equal to number of particles divided by 6.02 into 10 raised to power 23. Rearranging the above formula, as we have the number of moles in the question, so the number of particles is equal to number of moles multiplied by Avogadro number. So we get 1.66 into 10 raised to power 24 formula units of HCl. The second question is find the moles of 38.9 grams of oxygen gas. The solution is, as you know, the molar mass of oxygen gas is 32 grams. So 38.9 grams divided by 32 grams oxygen, we get 1.22 into 10 raised to power 0 mole of oxygen.